In this video, I'm going to go ahead and we're going to round out our in-memory services a bit. So, as you saw in the last video, when I edited my profile, the progress bar didn't display at all, despite the fact the code was there to display the progress bar. That's because the process happened too quickly. The event was the request was posted, and the response was posted immediately on the same thread, which showed the progress bar, then hid the progress bar immediately. We want to make it so there's a bit of a delay in between our response and our request events. So let's go ahead and do that. I'm going to jump into Java in memory, and what I'm going to do is I'm going to create a base in memory service. So I'm going to right click our services namespace, or package rather, and I'm going to create a base in memory service. Now inside the base in memory service, I'm going to create a couple fields. I'm going to have a protected final bus, a protected final your application, and then I'm going to have a protected final handler, and a protected final random. For my constructor, I'm simply going to say, oh, by the way, I am going to make this abstract. Even though it doesn't really matter if it's abstract, I want to enforce the fact it's abstract. I'm going to write a protected constructor, protected base in memory service with a Yora application parameter. Then, in this constructor, I'm going to say this.application equals application, this.bus equals application.getBus, handler equals new handler. Whoops, I did not mean to do that. Handler equals new handler. Come on. Oh, I imported the wrong handler. Let's remove this import statement at the top and come down here and hit Alt-Enter, and I'm going to say import class, and I'm going to select Android.os handler. So make sure you are importing the correct type here. And then I'm going to say random equals new random. Finally, I'm going to say bus.register this. I can go just make that a little lopsided, kind of ugly. Okay, so what's going on here? We have our base in memory service. It takes in an application. Pretty straightforward. It aliases out the application to a application field, aliases out the bus to a bus field. Then it creates a random, and the random is going to be used to generate random timings. And then it registers the bus, registers this object to the bus. But notice this thing right here. What's that? Basically, a handler is a object or a class in Android that is very, very convenient when dealing with multi-threaded code and synchronizing access to the main UI thread. Basically, what I want to have happen is I'm going to use this handler to delay a message. Basically, I want to be able to run some code in the future on the main UI thread. And I can do that with the handler object. And in a nutshell, that's what a handler is and what it does. All right. So now I'm going to make a series of methods. I'm going to start off with the simplest one, and I'm going to work out, or sorry, not the simplest one, the base one, and work out as I go forward. So I'm going to make a very simple method. It's going to be protected void invoke delayed. And invoke delayed is going to take in a runnable long millisecond min and a long millisecond max. And then I'm going to say if millisecond min is larger than millisecond max, throw new argument or illegal argument exception. Illegal. Okay. And then the message is going to be min must be smaller than max. And we'll leave it at that. Just some basic testing there to make sure we don't accidentally pass in incorrect parameters. Then I'm going to say long delay equals. Then I'm going to say if millisecond min or if millisecond max, or well, I guess what I can do is I can just do this. I can say cast to long random dot next double multiplied by millisecond max minus millisecond min plus millisecond min. So this is a really, really simple formula to get a long or some sort of integer between two numbers. All we do is we take the next double, the next random double, which is going to be a double between 0 and 1, and we multiply it by this difference between the max and the min. So let's say the max is 5 and the min is 3. That means this code is going to result in a number between 0 and 2. Then we add back in the millisecond min, so it's never smaller than millisecond min. Pretty straightforward. Now what I'm going to do is I'm going to say handler dot post delayed runnable delay. Pretty straightforward. All I'm saying is, okay, now I have my delay, and I have my runnable, which was acquired as a parameter. Now let's go ahead and run this runnable after this delay. So what's a runnable? Runnable is just an interface. It's an interface with a single method. The single method, not surprisingly, is run. That's it. So basically, what I'm saying right here is for the handler to invoke the run method on the runnable object when the delay occurs, or when the delay has expired. But don't block the UI thread. And most importantly, when you run the runnable, make sure it's running on the UI thread. All right, let's go ahead and make some convenience methods. I like convenience methods. Let's go ahead and make a convenience method that posts an event to the event bus after a certain delay. So I'm going to say protected void post delayed, and we're going to pass in final object. Then we'll do event. We'll call this the event. Long millisecond min, long millisecond max. So how do I make sure you do qualify this parameter as final? That's important for what's going to happen next. How do I do this? How do I write this post delayed method in terms of invoke delayed? Pretty simple. I invoke delayed. For the first parameter, I pass in a new instantiation of runnable, and inside the runnable, I do bus.post event. That again is why this event parameter needs to be marked as final. Otherwise, we wouldn't have been able to access it from within the closure. Now what I'm going to do is for the other two parameters, I'm going to pass in millisecond min and millisecond max. And now I've successfully written this method in terms of the invoke delayed method. All right, let's go ahead and I'm going to go ahead and do another one of these simple, straightforward ones. I'm going to say protected void post delayed. I'm going to say object event, and then I'm going to say long, and then I'll say milliseconds. So this overload is going to invoke post delayed, and it's going to pass an event and milliseconds and milliseconds. So this one is not going to be a random amount of time between 2 millisecond min and milliseconds max. It's just going to be milliseconds. Then finally, I'm going to create one last method, post delayed, that takes in an object event and simply invokes post delayed with event, but passes in 2 arbitrarily chosen delays. And let's do an arbitrary chosen delay between 600 milliseconds and 1.2 seconds. So that'll give us, I think between 600 milliseconds and 1.2 seconds is a good sort of range for simulating network lag. Especially on a phone, anyway. All right, now that we have this, let's go ahead and see how we can use this fancy new class. So let's jump into our in-memory account service, and let's have it extend from base in-memory service. By having it extend in base and memory service, I can do quite a few cool things. I can get rid of this application field because it's provided by base and memory service. I can also get rid of this code that registers the bus with this new this new class, or this new object, and I can also get rid of this code, obviously. However, I am required inside the constructor to invoke the only constructor on this base and memory service. Because we are not using a parameterless constructor here, I have to invoke this constructor from the child class. So to do that, I use the super keyword and pass an application. So see how using the base class has already cleaned up our code. We don't have to manually register ourselves at the bus. We don't have to alias out fields. We can just invoke the super constructor. So now what I want to do is, instead of saying application get bus post, I'm going to say post delayed, and I'm going to pass in response. In fact, I'm not going to. I'm going to keep it like this. So I'm going to say post delayed, pass in response. So now let's hit play. So by invoking post delayed, it's going to post this object after a certain delay. So let's do login, log in, open up profile. Let's hit edit. Let's hit OK. Now check that out. Updating I don't know if you guys saw it because of the lag, the latency with the video recording, but my progress bar did appear momentarily. Let's go ahead and test our rotating code. So for post delayed, I'm going to temporarily set it to 4 seconds. So I'm going to hit run. So let's go ahead and hit OK, and then there's 4 seconds. Notice how it sits there for 4 seconds, and then it should go away. Let's do that, but that's immediately rotate. Notice how I rotate, it still says updating profile, but check that out. The progress bar goes away when the event that indicating that it successfully set the profile has been received by the activity that wasn't even the activity that initiated the initial request. So that's really awesome how we can initiate a request from an activity and then that same activity gets destroyed and recreated, and the recreated one gets that event. That's one of the strong points of this architecture I came up with. All right, so let's go ahead and rotate again. Okay, so now I want to test error reporting. So what I'm going to do is inside of my dummy code, I'm going to say if request.displayName equals Nelson, then I'm going to say response set property error display name, and then set the error to you may not be named Nelson. Oh, I forgot. This is Java. Why was I comparing this by reference? Oh, I'm glad I caught it before the code didn't work. But I really want to point this out to you guys, especially you guys coming from C#. I don't know if we've done any string comparisons yet in this entire series, but this is one of the biggest things that a C# developer, or really a developer of anything that isn't Java, is going to have a slight problem with when transitioning to Java, and that is string comparison. In Java, strings are, like every object, are reference objects. And as a result, when you do and there's no operator overloading. So as a result, when you do an equality check between two reference objects, what you're getting is a reference check, not an equality check. So this code literally says if the variable here, or if display name is pointing at the same object that this string literal is, which will unlikely ever be true, then do this code. It's not saying if this request.displayName equals this string Nelson. To do that, we have to manually invoke the equals method. I'm really glad that I caught that before embarrassing myself even more in front of all the people that are watching in the future. All right, so let's go ahead and say login, profile, hit that. Now let's change my display name to Nelson and see if we get an error. So let's hit OK. It says updating profile. Check that out. So the error came back. We went back into edit mode, and it showed me my error. You may not be named Nelson. So that's an example of our error handling. And that's also an example of how we can use this fake service layer to really test our entire application without having to have a network connection. And I think that's an incredibly important thing to do for all you guys who are out there writing your apps. It's why I'm introducing a relatively complex architecture in an introductory series. And the reason I'm doing it is because just inherently dealing with the activity lifecycle and device rotation and asynchronous code, it becomes so convoluted when you don't have a clear separation of concerns. So I introduced complexity to get rid of complexity, is basically what I'm saying here. Instead of hard coding our code to do particular things, we now have a flexible architecture where we can change the behavior of our application without changing the user interface. And we can write the entire user interface in isolation of an internet connection. And we can introduce our own test cases like this. And if you wanted to get really fancy, you could write your own automated testing, both automated unit tests as well as integration tests and end-to-end tests, all with using this architecture. So that's why I introduced this sort of kind of complex thing in an introductory series, so that our code becomes simpler, and I don't have to show you guys the code that would result from not doing it this way, which would be massive activities. It's really funny in programming how simpler things are more complex usually, but that's pretty true for most of programming. The more powerful of an architecture, the more complex the architecture, the simpler things become. If you do it right, anyway. Some architectures are just ridiculously complex and also complex at the same time. All right, so now that we've done that, let's go ahead and give the same treatment to our updating our camera, our avatar, as well as updating our password. So to do that, I'm going to say subscribe, public void, and let's do update avatar. And I'm going to say account.update profile, or sorry, change avatar request. Then what I'm going to do is simply say post delayed, passing a new instantiation of account.changeAvatar response, and that'll be it. I'm not going to worry about setting any errors here. And I'm not going to use any of the details from the request. Now let's do our change password. I'm going to say public void change password, account.changePassword request. And first I'm going to say if request dot new password, or if not, request.newPassword.equals request.new confirm new password. Then I'm going to say, or I need to create the response object first, obviously. So I'm going to say account.changePassword response equals new account.changePassword response. And then I'm going to say response set property error, and I'll say new or confirm new password. Passwords must match. I can also do some basic validation here, some placeholder validation. I can say if request dot new password dot length is smaller than 3 characters, then response set property error new password must be larger than 3 characters. And then finally, I'm going to say post delayed response. I'm just on a roll here with my typos today, aren't I? Let's go ahead and just use the awesome spell check there. Okay, so that's my change password and update avatar. So now let's go ahead and hit play and see how that affects our code, or at least affects our user interface. So let's log in. Go into profile. Let's change our avatar first. I'm going to select from camera. Hit select. Hit OK. And then select that. Hit done. Now check that out. You saw, I don't know if you guys saw it, but the progress dialog, or the progress bar thing, came up on our avatar for just a moment. Now let's change our password. I can type in garbage here, hit update, says changing passwords, and our changing password dialog our progress bar does not go away. That's really cool. I just showed you guys a bug. Now, it's obviously my fault that the bug exists, but what's awesome is I just showed you guys an example of this whole process exposing a bug already in our user interface logic. And that is, notice how the progress bar or progress dialog box was not dismissed when the response came in. So let's fix that. Let's jump into our activities our dialog, change password dialog, and then down here on our password changed, make sure that we say progress dialog.dismiss and progress dialog equals null. Now let's hit play again, and let's see if that code works. Oops, not well. I don't really care if I'm registering or creating. Let's go down to profile. Let's go ahead and hit change password. For the password, let's type in garbage, hit update, change password, and we got an error. Passwords must match. Let's make the match. Hit update, update changing password. Ooh, the changing password dialog doesn't go away when it is a success. Another bug. So let's move our progress dialog code up here that dismisses the progress dialog, and let's move it to the top of this method, because I think that's where it should have been to begin with. I'm going to roll here with A, spelling, and P, line placement here. Okay, let's do this for reals this time. And say test, 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 update, changing password, and dismissed. Password updated. Now I can say, now notice how the current password appears now because I set the user to have a password. For new password, I'll do TE. Confirm, I'll do TE. Hit update. Changing password. Oh, and we have an error. Passwords must be larger than 3 characters. So that's it, guys. An example of really simple use case with our service layer. So with just this little bit of code, and yeah, this code isn't useful for the actual end game application. The real application is obviously going to hit the internet, and the real application obviously needs to be tested as well. But with this little bit amount of code that we have right here, we're able to test all of our interaction logic in the absence of a internet connection. And I think that's awesome. So I hope you guys do too. And yeah, I think that pretty much wraps up our profile page. Our profile page is pretty awesome at this point. So really now what we have to worry about is hooking up our... Oh, come on. Oh, well, we're going to have to worry about hooking up our logout button. Hooking up our login and our register methods to our fake in-memory service. So now we'll be able to actually see our progress dialogues inside of our login and register methods. Anyway, we'll do that in the next video, and we'll see you guys then.